Okay, so no problem, no problem. So closed means you can't go anywhere. Now, I'm not talking as per the lecture, I'm not talking about your joints. Your joints can move, but literally your distal segments, what's representative at the end of your roads, your hands, your feet, those aren't allowed to go anywhere. So you think about when you're doing a push-up, do you want your hands to slide off from the floor? No, you'd fall to the ground, right? So it's important to close the roads that are your hands. When you're squatting, do you want your feet to slide anywhere? No, it's important to close the roads when your feet are on the ground to do certain exercises or tasks so that you don't slip slide, right? So closed has nothing to do with joint motions. You're still going to have joint motions, but it's the difference between, can your hand literally move forward and back? Like if you're doing a chest press, your hands are open to move forward and back. In the push-up, your hands are closed. They do not go forward and back. It's that simple. It is that simple. So you think about a pull-up, same thing. If you're doing a pull-up, your hands aren't allowed to do this, right? So think about the difference between a lat pull-down machine where I grab onto the bar and my hands are allowed. They are free to go up and down, to move in straight lines. They are open to move linearly. They can go up and down. In a pull-up, my hands stay still and my body goes up and down. So it's the same joint motions, same muscles. So what makes them different? The pull-up, my roads for my distal segments, in this case, my hands are closed. My hands aren't allowed to go up and down, and my hands aren't allowed to go side to side. In a lat pull down, my hands are free to go up and down. So that would be open. So the differences between these movements are based on distal segments being fixed or movable. And I encourage you to go rewatch the lecture so that maybe you could hear it again after I clarified it for you. But that's important. Don't just look at the support materials. Do not just look. So you like for human movement exercise sheet, you're looking at the support materials, which is good, but I also need you to go listen to the lectures where I explain the support materials in more detail. I'm not saying you didn't, but I'm saying that if you bring that together, then it'll be a much better understanding. Okay, thank you for that question, Jasmine. Any other questions? Or if you have a follow-up question, maybe I didn't do a good job of answering that question, bring it on. Re-engage and clarify, and I'll be happy to give it another shot. My neck's a little tight today, guys. Sorry for the chronic stretching. Okay, Jasmine, did you get my email? It seems like you're asking questions based off of just the notes, and it's important that you ask questions based off of the video lectures. because it's in the video lectures that I say, hey, this is what's important. This is what's important. The notes have a lot of stuff into it. So in the video lectures, I extract the important stuff for you to understand with collinear vectors, not being one of them in terms of the definition. You're going to need to know what vectors are. What's the difference between a vector and a scalar? But picking out little pieces in the book may not be reflective of what I'm holding you accountable for. And don't we want to just know what we're held accountable for, right? So I implore you to please go to the video lectures and hear exactly what I say, guys. This is what you're going to know. This is what's important here. This is what's important there. And then the Word docs are support materials for the things that I told you to spend time and energy learning. I'm not going to ask you the definition of a collinear vector, but I told you that, again, what I'm going to emphasize on the videos. Okay. Now, if you're just wanting some clarification on what it is, so vectors can be summed if they are in opposition of each other. They can be canceled out. They can be added. But certain vectors can be applied at the same point. So what that means is that if, let's say again, I'm just answering your question. I'm not going to ask specifically define what collinear vectors are, okay? So I'm trying to answer your question, but at the same time, I don't want to overburden you with information. But where two different forces in two different directions, now I'm not talking about in the same up, down, left, right. I'm talking about perpendicular direction where they touch, where they meet, and you have a resultant because of it, right? So it's where two different forces connect at the same point is different than two different forces that are in the same plane or in the same dimension. Does that make sense? So it's like if you're trying to push on this book and you give an upward force and a cross force at the same place, well, I think pushing off of the ground would be the best. If this was your foot on the ground, some of that force is down and some of that force is friction. And both of those forces are in the same exact point. And this plus this equals the blue pin. So your resultant force is a combination of an X and a Y force that's on the same point. Okay. Versus the other kind of force where you're just looking at one of these plus one of these. If this one's bigger than that one, they cancel out and then you get a leftover this way, right? So the important thing is that these kind of forces can be added, subtracted. These kind of forces have to be trigonometried because I can't add this plus this. They're in two different directions. I can't subtract this plus this. They're in two different directions. I got to do trig with that to make relationships between forces and angles. The ones that are in the same direction, I can cancel those out. I can add them. I can subtract them. Okay. So again, being that this is online and this is really tough, I'm really going out of my way to try not to overburden you with little detailed like definitions like that. So, but it's a great question. I'm glad you asked it. But just stick to the key points in the videos and you're going to be fine. Okay. Follow-up question? Cade, that the first inclination, first of all, thank you for your question. It's a great question. If we're clear that when you say length of the lever, it's important that we employ that it's the length of the lever arm or force arm or resistance arm. In other words, it has to be relative to the force application. What I mean by that is if I have, let's say I have this segment, right, and it's rotating about my finger here. Well, if I apply a force parallel to the axis, I'm pushing down on the pin, it's not trying to rotate, right? I have to apply my force perpendicular. So what if I doubled the size of the pin? If I increase the length, but yet I still apply the force in the same direction, I don't change the lever arm. I increased the length, but I didn't change the moment, right? Or if I have a torque that's here and all of a sudden I supply an angle force, so some of it's parallel and some of it's perpendicular, well, then I change the moment, but I didn't necessarily change the moment arm. So I'm going to clarify this by saying if everything stays the same, in other words, if the force stays the same, if the perpendicular distance stays the same, when perpendicular distance, the force application is the same. The longer my lever arm, the greater the torque of that said force. Yes. So in other words, for me to truly feel comfortable with saying, yes, Kate, absolutely, I need to set up these parameters to make sure that there's no outside variables to influence the torque, right? Because what if you increase the lever arm so you have the potential to more torque, but you don't push as hard? Does that make sense? You could have the same torque or you could have less torque even though you increase the lever arm. So you have to create some consistencies. If the force stays the same and you increase the lever arm and the force perpendicular stays the same, then yes, your moment or torque will go up. So that's a great question. I might ask a question like that, but I want to encourage you guys that I'd have to create consistency. Correct, and the same force, right? So in the sense that the same perpendicular force was applied, yes. Longer moment arm, greater torques. Greater the perpendicular distance, great. And I'm not quite sure if I gave, again, these are analogies, not concepts, but if you go to any door, where's the door handle relative to the hinge? Far away, to make it easier to apply your force to influence the motion of the door. Try to open a door pushing on the door right next to the hinge. You still have a moment arm. They're still somewhat perpendicular, but you have to produce a ton of force to create enough torque to open the door, right? That's one way to look at it. So if in that example, in that little science experiment, if I gave the same exact force, I had like some little push pads where I knew I gave like 5 pounds of force, and I did it close to the hinge of the door. Let's say this is the hinge of the door opens and closes like this, right? If I push 5 pounds here, then 5 pounds here, then 5 pounds here, then 5 pounds here, right? So that's an example of what I think your question was about. If all things are equal and I'm applying the same amount of force in the same direction, perpendicular, the further I apply it out, the longer the moment arm, the greater the torque, the greater the moment. Yep. And if you don't mind following up with a comment, Kate, that I finally got to what you were asking and that I did a decent job of clarifying that for you. Oh, okay, great. Yeah. So now I see the application question here. Yes. One of the important things of this lecture is it's not the weight, it's the moment. Especially for human movement, it's not the weight, it's the torque. Too many times we look at dumbbells and we say a 5 pound, that's light, a 10 pound, nothing, 20 pound. But for our joints, a lot of times it's not the weight, the weight that I have in my hand and the weight of my arm. It's how far is that sucker away from my body. I can hold 75-pound dumbbells. Why? Because it's passing parallel to my shoulder. My shoulder's not doing any work. It's just plumb bobbing there. I cannot put the 75-pound dumbbells out to the side. Yeah, because it's not about the weight. It's about how far away is that weight perpendicular to my shoulder. So to answer that specific clarification question, absolutely. 20-pound dumbbells here is easier on my abductors than 20-pound dumbbells out here. Even though the weight is the same, the mass is the same. What changed? The moment arm. The force didn't change. Weight's still the same. Force stayed the same. So what made it harder here versus here? How far I'm applying that force away from the door. Yep. And I will have some questions like that in terms of just practical, hey, where is the moment the greatest in this range of motion? You know, from here to there. And as you recall from the video lectures, that's what's great about machines. Look, man, machines can be great. They're expensive and they take up a lot of space. That's not good, but they create more consistent torques, more consistent moments. As the machine is pushing you here on your legs, as you go up through your range of motion, the machine changes its direction of force to stay perpendicular. So machines have more consistent moment than free weights, dumbbells, ankle cuffs. And that's important for you guys to know. This is not Campbell saying this exercise is better than the other. It's just you have to know the limitations. You have to understand that if you're working with someone at home health in their house and all you have is ankle weights, you have to understand that I may do a few repetitions here to there where the torque is the greatest at anatomical, and then reposition their body and do some of the repetitions here where the torque is greatest at 90 degrees flexed. Cool. Sorry, I had to go through Lake Charles to get to Opelousas, but thank you for following up to steer me in the right direction. Give me a thumbs up or are we cool? And then I'll open it up to any more questions. Great question. So I know there are going to be questions like that. Practical questions. I'm not going to ask you guys to really define and go. It's just, hey, what's easier, this or that? Where's the moment the greatest for your muscles in this position or that position? That kind of stuff. Again, if you go back to the video lectures, I really tried to emphasize, guys, this is the important stuff. This is what you're going to need to know. This is it. Because again, this is new, right? This is different. I've never taught online before. So I need to really streamline your focus and say, this is of importance. This is of importance. This is how I'm going to ask this. This is how I'm not going to ask this. That kind of stuff. All right, next up, Jasmine, I want to get another question from you, buddy. I know you got another question in that brain of yours. I want to make sure you make an A on this test. We can do it too. You know, it's while I wait for you guys' questions, there is nothing that I gain if somebody doesn't do well on a test, because then that reflects poorly on me as a teacher. I want everyone to do real well. You know, I want to teach you guys information practically so that you can answer these questions correctly. That is a benefit of that. That's something that I enjoy, right? It's a benefit of teaching. So I want everyone to do real well. So let's talk about ways, while I'm waiting for my next question, that I'm going to do to help you do well. Know none of these, if you've talked to any students that used to take my test in person, they hated the none of these answers. It was answer choice 5. There was always 5 answers, and some of them were none of these. And I would toss in none of these every now and then just to make sure you knew what was going on. So the fact that I eliminated that gives you a better odds of guessing, but it also takes out the none of these to mess with your head. Well, what if he, maybe there's an exception? None of that. Every answer has an answer. Sometimes I've accidentally given 2 right answers on a question. You got a 50% chance of getting it right. So my mistake is your, remember in Monopoly, bank errors in your favor, collect $200. Campbell erred in your favor, collect 2 points. This test should be very different than the last test. Last test was just straight muscle function, right? This is more mechanical principles, more traditional biomechanics. So you don't have to, well, I did real bad on the first test. Look, man, maybe muscles aren't your thing. But understanding these motion concepts and movement strategies, and remember, I'm not going to ask you to solve F is equal to ma. I'm going to ask you to understand F is equal to ma. How do unbalanced forces influence motion, right? This goes up, this goes up. This goes down, this goes down. The ma, as this goes down, this goes up, right? Oh, Jasmine, what a good question. So if you go back to watch the lecture, everything is force, right? Weight is force, muscles force. So what we do is we differentiate the forces with these terms like resistance. And so in your levers, F, even though everything is a force, even resistance is a force, weight is a force. So in the lecture, when you go back and rewatch it, because I know you will, you're going to hear me say F is your muscle. We're gonna designate that as muscle force. That's what your muscle is doing to the mechanical leverage. And the R is going to be your resistance. What's resisting your muscles, right? The weights, gravity, external forces. So so you are 100% correct, but not just for first class lever. For every class of lever that we are applying to our body, R is going to be the external. So you remember in 310, we talked about what's the external force trying to do to you? That's R, the resistance. What's resisting your muscles influencing that motion, okay? So you're correct, but I want you to understand you're even more correct if you apply that to second class, third class, all classes. The R is the external, R is the resistance. Thank you for that question. Now, again, guys, the link, I sent you an email and I asked, nobody's following it, but listen, I'm going to give y'all some leeway because at least you're asking questions. But in the email protocol, I asked you guys to say, in this lecture, and then ask your questions. So that way I know that you listen the first time I tried to introduce you to these concepts. I understand some of this stuff needs to be clarified, but by you telling me or showing me you listen to it, it really does help me trying to develop it. This video should not be me introducing this material to you. It should be mastering. You get introduced to it maybe in the book, maybe it's, then you develop it by listening to the lecture. And then this is where I can help you master that material and truly understand it, okay? So again, my email asked that you refer to the lecture, but who cares? I'm just happy I'm getting some questions. Oh, Jasmine, did that clarify your question for the first class lever? The R is the weight, resistance, external force, right? And remember, that could be second, third, doesn't matter. R is external force. So give me a thumbs up or that works for you, that answer. Yay, awesome. Yeah, R is resistance. And anytime you see R for our class, that is going to be the outside forces, external forces. Also, I'm going to post this video to your Moodle for tomorrow. So that way, if you want to rewatch it or re-listen to a couple of my clarifications, but like I said, guys, I can't stress this enough. You're looking at the support materials, which is great. Always kind of start with the support materials, but then the lectures is what's going to make sense of that stuff. And then after you introduce yourself with the support materials, develop it with listening to my lectures where I try to connect those support materials, then these are the kind of settings that we can use to make sure we're all on the same page. All right, guys, last call. Last call for questions. I say last call. We'll talk as much as you want, but I don't want to like stare into my computer for like 20 minutes. Kind of awkward. Okay, well, if you do have any questions, you let me know. Like I said, I want to emphasize to anybody who's watching this now or who might watch it later, the support materials are great and they're important, but it's the audio, me explaining how things like the example with the chains, when you go back and watch that, it'll be like, oh, okay, I see. It's not about the motion is open and closed. It's literally about my hands aren't allowed to move, or my hands are allowed to move. It's about my feet not being able to move, or my feet being able to move. Okay. All right. If y'all need anything else, y'all let me know. The hard part's over, guys. The only thing we got left is that test, and I'm sure all of you guys are going to do very well. Y'all have a good day.